And so I am David Morris, and yeah, I'm just going to talk a little bit about myself first. I mean, I started off as a games programmer for LA Noir, doing camera systems. Then I worked on Happy Feet 2, doing real-time and image catalog. And then I started getting more and more into making little hacks for the movies. Like we needed a multi-camera HDR time-lapse rig thing. So I said, hey, you can do this, and I put up my hand, started making that, and then I was working on Mad Max 4 last year in Namibia, making hardware, managing other systems on that. And well, the reason I'm saying this, like, why am I talking about this, is because I went from a programmer to kind of like a hardware hacker with no formal training, unless you count YouTube or Wikipedia as formal, but you can. Well, some people do, right? But yeah. So I can relate what it would be like to go from software geek to like a hardware geek, and that's kind of like what I've been doing. And so even you might want to make your own little electronics. This is kind of like a little bit of way how to do it. I mean, it can be quite daunting just going from something that's pure data into something that's an actual physical product. And yeah, so it's a bit of a wall there. And by the way, since I have no formal training, whatever I say, take it with a grain of salt. So just to base what I'm kind of like going to be doing is just on the Arduino. Everyone knows an Arduino, it's very simple, has some inputs, outputs, but as it is, it doesn't actually do much. Just like if you have a computer with no screen, no network, no nothing, it's kind of boring. The only thing you can do is like blink the little LED, and that gets very boring very quickly. First one I bought, that's the only thing I bought, and that's the only thing I could do with it until I bought some more stuff. So what you typically do with Arduinos is you have little shields which kind of like expand on it. Like you have like LCD, you have GPS, or like little joystick module. You can just do something with it. So I'm just going to be using this to base my example of how to make your own little electronic stuff. So, first of all, you start with your idea, which is the hardest part. After this, everything's simple. Well, kind of. So imagine this is the thing that you want to make. You have a little idea, that's a little joystick to control whatever it is, like a main box or whatever it is. So step 2, breadboard it. Have a billion cables. Go everywhere, just make sure that they work, make sure the connections are there, make sure that basically you don't blow up some electronics, or make sure you do blow up if that's your aim. I mean, you can solve it there. I mean, I've actually used breadboards on final products on movie sets, so when the need is there, you kind of use it, but the wires are falling out and it looks like crap. So step 2, you can use a protoboard. It's just soldering the connections up, basically the same thing, just soldering it up. But that takes a lot of time, it's really ugly. But you can do that, and then step 4 will profit, like in all things. Or you can make your own. So based on the little joystick thingy, that's that, by the way. So that's the schematic. So in electronics you have two parts: the schematic and the board. The schematic is basically the logical connections between all the different components. So that's a joystick, that little thing. Obviously, physically, it doesn't look anything like that, but logically, it looks exactly like that. So the connections are there, voltage goes up, things. This is the Arduino, which is the actual pinouts, the shield, other buttons, etc. The green wires are to connect, say, this pin to that pin, that other pin to this pin. And you can have names like this one is logically connected to this one over here. Even though they're not physically connected, they're logically connected. So, like that's you wire it up logically like that, either based on your breadboard or based on your own ideas or whatever, and you do that. There's a whole bunch of libraries you can use. SparkFun has a whole bunch of libraries. You can make your own parts and stuff, so it's actually relatively simple to make these things in the software. And once you've got that in the software, you go to the Borden View, which is, this is what it physically looks like. So down here, that's the actual joystick again. Those are the buttons. This is the shield, and the software just like kind of plonks all the little components next to each other. Can't really see it that well, but there's little wires here, but I'll talk about them later. And it's your job to actually put them where you want. So, for example, in a joystick, it makes sense to have an actual physical connection, an actual physical placement of where you want the joystick to go. Sometimes you have restrictions, like if it's something that gets very hot, you need to put it this high so you can put a heat sink. Or something that's very high-speed data, you need to put them together because the speed of light is very slow in compared to some electronics. So basically, put them what your electronics dictates, and that's kind of like what it looks like. The joystick over there, buttons over there, there's a little reset button here, done. But can you see the little faint lines? Mm-hmm. Like little hardly.
Yeah.
Trust me, they're there. So the little wires connecting from this pin to that pin over here, this one to here, they're called air wires. Basically, that's what you drew up in the schematic, saying this is connected to here, but you actually haven't put anything down there for it. It's like an air wire. So that works great with wireless, but when you're actually making physical things, they don't work. So it's just basically saying you have to wire these things up, and then you go and wire it up. And you still can't see it. Okay. There's blue tracks here, red tracks here. Can you actually see them at all?
Maybe.
Yeah, you can, right?
Come closer.
Come closer.
Yeah.
Yeah, so you have blue tracks, you have red tracks. The blue tracks are on the bottom layer, the red tracks on the top layer. I mean, this is a two-sided board, so you basically, sometimes you need to cross tracks, or you can't obviously cross them on top of each other. That's bad, as Ghostbusters told us. You have to go in different layers. So this is a two-layer board. Most modern motherboards on computers would have anywhere between 6 to 16 layers, and I've been told that anything above 19 layers is silly. So it's possible. It's sometimes very, very silly to do 20, 30 layer boards. They just make them by just stacking them up all on top of each other. But so you lay down the tracks. You can get software to do this for you, but unless you're willing to pay a ridiculous amount of money, like millions and millions of yen, it does a really bad job. And even with those ones, you do have to kind of give the software a lot of hints of where you want them to go. Sometimes you need to make tracks bigger because they carry current. Sometimes you need to make them thinner because they don't carry current. Sometimes you need to actually make them the same length because they have, anyway, it gets complicated. As I've been finding out the hard way, making a lot of things and stuffing a lot of things up. The software will tell you basic rule violations, like if you put two tracks on top of each other on the same layout, say, hang on, you're not doing this right. If you put components on top of each other, you're not doing this right. If you left something unconnected, it's saying, hey, you're not doing this right. But basically, it tells you off quite a lot, which is a good thing. So after this, you generate some files called some Gerbers. Well, I actually have no idea how to pronounce this, but it's Gerbers. I just call them Gerbers. But it's basically like a PDF or like an SVG. It's a vector file which tells the fabricator how to lay down things. So you have the red line, which tells it how to cut it out of the actual circuit board. You have the blue layer. This has nothing to do with the colors from this layer. From this layer, it's that one. The blue just means copper. The green means where there's a pin going through. You can't really see it very well here, but this is text. So it's like on this board, so you have like white over the green. And so basically, it's telling the fabricator what layers to put down in which order. So you have the drills go first, then the copper tells them what part of the copper to take away or what part to leave. Then you have the solder mask, which is the green or the red paint, which is to stop solder getting everywhere. Then you have the silk layer, which is the text, like your logo or to say what pins are where or things like that. And then, I mean, that's you can have more layers, but that's just complicating things for you guys, so I'll leave it at that. And then you send it off to the fabricator and you get back some boards. These are a couple of my boards that I've made. This one is this one. Which is great, but then you get to look at the board and you get to repeat the whole process over again because I'm pretty sure you've made a mistake somewhere. Like I did, I just totally stuffed that one up, so I had to send it off again. So it was a lot of fun. So that's basically the steps. Like you design, you draw it up in the CAD, you make sure that you don't have any rule violations, and then you just send it off to fabricators. I mean, they're getting incredibly cheap. Like a 5 by 5 centimeter board will cost you like 2,000 yen with shipping, like to make 10 of them. So it takes 2 weeks, 2,000 yen. Try it, give it a go, and that's basically kind of it. There's a few links there of places that are really good to look at, especially Seed Studios. Maybe if you're actually into some of this, you've probably heard of it. Spark Fun. Software that I use to make it is Eagle, which has a decent hobby version that's limited to size and 2 layers, which is more than enough for most hobbyists. And yeah.
One question here. Does the software use do simulation whether your board is working? Like can you do that? No.
No. If you want to do actual proper simulation, you have to go to the really expensive ones, and they only do electrical simulation, not logical simulation. So, say, what happens if I send this electrical current down this track? How does it affect other tracks? Yes.
But you can always simulate the logical in the software, right?
Yeah, you can use. I mean, there's a program called LT Spice, which is incredibly annoying to use. It was made in the 70s, I think, and I think they haven't upgraded it since. Especially the user interface, and that you can use that too. I mean, it's actually really good for simulating the very basics of electronics, like what happens when you put 3 volts here, 5 volts here, and a capacitor in between, and you can see all that type of stuff. But yeah, I'll use it a bit. Please have a look at the boards. Most of those aren't working, so don't feel bad to break them. Except the big one, I want that one.
So what have you built so far that's working?
That's working.
Yeah.
This was version 3 of a board that I'm currently working on. I'm up to version 11 or 12.
So what does it do?
This is a data logger, so it gets data from several sources and writes it out to an SD card. So the reason I'm working on this is because it's a data logger that reads timecode. One of its inputs is a timecode generated by a timecode machine. That's the same timecode that you feed your cameras, that it's in lockstep with the frames. So all the data that it writes out to the SD card is frame aligned. So then it's a lot easier to bring it into some post-processing software. So that's what I made. I mean, I have made other things. I used second variation of this guy on Mad Max. Quite successfully, except that they changed the cameras at the last moment and then we couldn't actually use it. But, so I have made some things that work. I mean, this one does work, but it just had some issues. Yes.
Since when did you start to make electronics like that?
About 2.5 years ago. Basically, I had one of these in one of these Arduino things and said, we need a time-lapse trigger that can do this and this and this. I'll just grab one of these and put the LCD shield on it, like the little LCD, and then just plug it into 4 cameras, and it worked. And the first 2 iterations were literally this with the battery, with a band, not band-aids, rubber bands, and just stuck onto the camera. And I said, hey, that's kind of nifty. It was, yeah. That's how I got into it.
You told that when the all designs are ready, you send them to some makers.
Yes.
Which are the good makers? Is this Shapeways the best one?
No, Shapeways is a 3D printing company.
So which makers?
I'm currently using one called Hagvana. It's an Aussie guy that decided to go to live in China and make circuit boards cheaply. And yeah, he's nice.
Good one.
Well, it's not that he's good or not, because they all use the same factories. But he has some specials like 2,000 yen, 10 boards, 5 by 5 centimeters, or 7,500 yen, 5 by 10 centimeters. So they're kind of nice and it's cheap and cheerful. If you want some really good high quality boards, you don't go to him. But you go to him for hacking stuff.
Hobby level.
Yeah, they're great. I mean, that's what I use him for all my prototypes. And when I actually go get them fabricated professionally, I use someone else that has a different quality and they can guarantee that my boards will be correct. Rather than, yeah, it'll work. No problem. For a maker, because you get back 10. And as a maker, I use 1 or 2. I don't care about the rest. So you just choose one that's best. I haven't even opened this. Well, I've taken out 1 or 2 and then saw that it didn't work. Yeah.
I got a question. You've
Yeah.
got SparkFun on there as
Yeah.
like a source of parts, right?
Source of, yeah.
What about like local Japanese distributors of local
For
foods?
parts, I mean, I still found the easiest way to find parts online. Places like Mauser, Digi-Key.
Okay. So they'll no problem shipping to Japan. Maybe?
No, what, shipping to Japan?
Yeah.
No. If you order more than 7,000 on Mauser, it's free shipping.
Yeah.
And I've ordered stuff on Friday night and they arrived Monday morning.
I need to.
Yeah.
Sorry. If you want to ask more questions, again, talk to him after again. Thank you very much.
Thank you.